side view on the profile plane. You know that in these views, each principal surface appears in its true shape because it is projected on a plane parallel to it. You call these three views principal views, and these three planes principal projection planes, because they are mutually perpendicular. These three principal views describe this object completely. But you cannot describe an object clearly by three principal views if its most important surfaces are not mutually perpendicular. Take this lug, for example. In order to construct it, you would have to know the true shape of its slanting face. If you use the frontal, horizontal, and profile planes, and project three views as you have done before, you discover that you do not have a true picture of the slanting face. The front view shows it foreshortened. While the side view also shows the slanting face foreshortened. This happens because the slanting face is not parallel to either of these projection planes. You know that you can secure a true picture of a surface by projecting it only on a plane parallel to it. Therefore, you need to introduce a plane which is parallel to the slanting face of this object. This new plane is called an auxiliary plane. On it, you can project a new view called an auxiliary view. Because the projection plane is now parallel to the slanting surface, the auxiliary view will show that surface in its true shape. Since you are interested in the slanting surface only, you can disregard the rest of the auxiliary view. This is the whole story of auxiliary projection. It is simply projection on a plane which is not one of the principal planes. The auxiliary view and two of the principal views, projected as usual, describe the object completely, making the third principal view, here the side view, unnecessary. To visualize the views on the drawing paper, keep in mind the relationship of the auxiliary plane to the principal plane. This is the only factor which makes the construction of auxiliary views different from the construction of principal views. There are several different kinds of auxiliary views. The auxiliary plane may be perpendicular to the horizontal plane and inclined to the other two principal planes. Or the auxiliary plane may be perpendicular to the frontal plane and inclined to the other two. Or the auxiliary plane may be perpendicular to the profile plane and inclined to the other two. Or in some cases, the auxiliary plane may not be perpendicular to any of the principal planes. In the auxiliary view you have just seen, the auxiliary plane is perpendicular to the horizontal plane. That is, the auxiliary plane shows as a line on the horizontal plane, and this line is parallel to the top view of the face you want to show. But the auxiliary plane is inclined to the frontal plane, and it is inclined to the profile plane. This kind of auxiliary view, made on a plane perpendicular to the horizontal plane, is called an auxiliary elevation. An auxiliary elevation can be made on any plane perpendicular to the horizontal plane. In fact, on an infinite number of planes perpendicular to the horizontal plane, except those planes which give us the principal views, or principal elevations as they're often called. Because the auxiliary plane is perpendicular to the horizontal plane, the auxiliary elevation is like a front view in relation to the top view. That is, you can project distances from one view to the other. You will see clearly why this is possible if you observe the relationship of the views in greater detail. Notice that projection lines creating the top view can in turn be projected on the auxiliary plane. That is, they have their images on the auxiliary plane. Projection lines creating the auxiliary view have their images on the horizontal plane, just as projection lines creating the top and front views have their images on the front plane and on the horizontal plane, respectively. Consider the position of these images when the auxiliary plane and top plane are seen in one plane. The images of the projection lines become continuous parallel lines coordinating these two views. Obviously, then, points can be projected from one of these views to the other. The same coordination exists between the top and front views, of course. In making your drawing, remember that the auxiliary plane is perpendicular to the horizontal plane, because this relationship governs the construction of the auxiliary elevation. Auxiliary views must always be coordinated with the principal view, and in some cases, like this one, the two principal views will be completed first, and the auxiliary view constructed from them. To establish the relationship of an auxiliary elevation to the other views, imagine a datum plane beneath or through the object, parallel to the horizontal plane. From this plane, called a horizontal datum plane, distances on the object are measured. The horizontal datum plane shows as a straight line in the auxiliary plane and in the frontal plane. When the top and auxiliary views are seen in one plane, the edge view of the datum plane is parallel to the top view of the auxiliary face to be constructed. Therefore, after you have constructed the front and top views, draw the edge view of the horizontal datum plane on the front view, and in its auxiliary position, parallel to the edge view of the auxiliary face you want to show at any convenient distance. On this datum plane, construct the auxiliary elevation. Remember, of course, that as you have just seen, the images of the projection lines coordinate the top view and the auxiliary view. You can now apply this principle in construction and project one dimension of the auxiliary elevation by drawing parallel lines from the top view perpendicular to the horizontal datum plane. Since you know also that the height of the front view is the same as the height of the auxiliary view, you can measure the height of all points on the front view and mark off these same heights from the datum plane on the auxiliary view. This gives you the height of the auxiliary elevation, the height of the slot, and the hidden line representing the top surface of the base. Strengthen the lines of all the views, and the auxiliary elevation is complete. In making this drawing, you are able to show the true shape of the auxiliary face by obtaining both its dimensions from the top and front views, because the shape of the object accommodated itself to this procedure. In other cases, however, where the object has a different shape, it may be preferable to draw the auxiliary view directly from specification, because one of the principal views may be difficult to construct or may be unnecessary. With this object, for example, the ellipses on the front view will be hard to draw and are not needed. In making the drawing,